Imagine a world where instant travel is a reality. Picture yourself stepping into a device and in the blink of an eye, arriving at your destination. No more long flights, traffic jams, or wasted time. This might sound like something out of Star Trek. But what if I told you that scientists are exploring the possibility of teleportation using the principles of quantum mechanics? It's called quantum teleportation, and it's a mind-boggling concept that could revolutionize the way we think about travel and communication. In the realm of quantum mechanics, the impossible often seems within reach. Quantum teleportation, however, is not about teleporting physical matter, but about transferring quantum information, the fundamental properties of particles, across vast distances instantly. It's a process that relies on one of the strangest and most intriguing phenomena in the quantum world, quantum entanglement. This isn't just the stuff of science fiction, it's a field of active research with real-world implications. To understand how it all works, we need to delve into the bizarre and fascinating world of quantum entanglement, where particles are linked in ways that defy our everyday intuition. Get ready to have your mind blown as we explore the science behind quantum teleportation and its potential to transform the future. Quantum entanglement is a concept that even Albert Einstein, one of the founders of quantum mechanics, found deeply unsettling. He famously called it spooky action at a distance. Imagine two particles linked in such a way that even when separated by vast distances, they remain connected. If you change the state of one particle, the other particle instantly mirrors that change, regardless of how far apart they are. This instantaneous connection, seemingly defying the limitations of space and time, is what makes quantum entanglement so bizarre and so powerful. In the 1960s, physicist John Bell developed a theorem and experiments that proved that this spooky action at a distance was not just theoretical, but a fundamental aspect of the quantum world. Bell's work revolutionized our understanding of quantum mechanics and paved the way for exploring the potential of entanglement for communication and teleportation. But how do we go from entangled particles to teleporting information? The key lies in the ability to manipulate and measure the quantum states of these entangled pairs. By entangling two particles and sending one to a distant location, we create a channel for instant communication. In the next section, we'll explore the groundbreaking experiments that first demonstrated the possibility of teleporting information using quantum entanglement, bringing us one step closer to understanding the future of this incredible technology. The journey of quantum teleportation began in the minds of physicists grappling with quantum entanglement. For decades, it remained a theoretical curiosity. Many, including Einstein, were skeptical of its practical use. A new generation saw entanglement as a key to new frontiers. They asked, what if we could use this to transmit information instantly? This marked a turning point in quantum teleportation. John Bell's work laid the foundation for confirming entanglement. In 1993, physicists Charles Bennett and Gilles Brassard published a landmark paper. They outlined a protocol for teleporting quantum information using entanglement. This marked a pivotal moment in harnessing quantum mechanics for practical applications. Their method transferred the quantum state of one particle to another without moving it. Entanglement allowed information transfer even over long distances. This groundbreaking work spurred experimental demonstrations of quantum teleportation. Teleportation takes flight, the 2017 China experiment. In 2017, Chinese scientists led by Jianwei Pan teleported quantum information over 1,200 kilometers using the Messier satellite. Entangled photons were beamed from the satellite to ground stations, confirming successful teleportation. This groundbreaking achievement demonstrated the potential of quantum teleportation for long-distance communication. Beyond bits the quest for molecular teleportation. The successful teleportation of quantum information was a monumental achievement. Can we teleport physical objects as well? Could we one day teleport objects, maybe even people, across vast distances? This is where the concept of the molecular teleportation comes in. Imagine a future where objects are dematerialized, transmitted, and reconstructed atom by atom. It sounds like science fiction, but it's rooted in real science. Blueprints of reality scanning at the quantum level. Imagine a scanner mapping the quantum state of every atom. This could make molecular teleportation a reality, capturing detail beyond today's microscopes. determining each atom's type, location, energy state, and spin. A multi-dimensional map of quantum information. Quantum systems are delicate and collapse when measured. How to scan without disturbing the quantum state, recording, spin, or entanglement without altering them. These questions baffle scientists. Quantum computing might be the key. Quantum computers could analyze quantum information. Transmitting massive data is the next hurdle. We're talking about zettabytes or yottabytes of data. Rebuilding from quantum data. Imagine we've scanned and transmitted quantum information of an object. We have a blueprint of every atom and its quantum state. How do we reconstruct this data into a physical object? We need a device to manipulate matter at the atomic level. The energy requirements would be astronomical. And what happens to the original object? These challenges push the boundaries of physics and our understanding of reality. The quantum conundrum, where did it go? Molecular teleportation raises the question, what happens to the original object? Scanning captures quantum information and destroys the original. It's deconstructed at the source and replicated at the destination, like making a perfect copy of a document. The information is transmitted, not the physical object. Is the replica truly the same object? Section 2. A matter of matter teleportation versus. The concept of molecular teleportation challenges our traditional understanding of transportation. Instead of boarding a plane and physically flying across the Atlantic, you step into a teleportation pod. Your body is scanned on a quantum level, capturing the state of every atom and quantum bit of information. This information is transmitted to a receiving station in London, where it's used to reconstruct your body with perfect fidelity. It's the information that defines your physical being that's transmitted at the speed of light. New atoms are assembled according to your quantum information to create a new you, indistinguishable from the original. Is this form of travel truly teleportation, or is it a highly advanced form of replication combined with instantaneous information transfer? Section 3. The ethics of existence. What makes you, you? The possibility of molecular teleportation opens up a Pandora's box of ethical dilemmas. If we can scan and replicate human beings with perfect accuracy, what does that mean for our understanding of life, death, and the soul? Imagine a scenario where someone chooses to undergo teleportation. Their physical body is deconstructed at the source and a perfect replica is created at the destination. The replica has all the same memories, personality traits, and even the same birthmark, but is it truly the same person? Or is it simply a copy that believes itself to be the original? What happens to the consciousness, the soul, the essence of the person during this process? If we can create perfect copies of ourselves, does that diminish the value of the original? The ethical implications of molecular teleportation are profound and far-reaching. Section 1. A world without distance transforming everyday life. Imagine a world where physical distance is no longer a barrier to connection. Quantum teleportation could shrink our world, bringing people, goods, and experiences closer than ever before. Picture this. You're craving pizza from your favorite Italian restaurant, but it's hundreds of miles away. With teleportation, you could have that pizza delivered instantly. Online shopping would take on a whole new meaning. Order a new pair of shoes from a boutique across the globe and they could be on your feet in seconds. Global trade would be revolutionized, eliminating shipping costs and reducing delivery times. Imagine stepping into a teleportation pod and instantly finding yourself on a beach in Bali. This interconnected world would come with its own set of challenges. Section 2. Healing at the speed of light, revolutionizing healthcare. The potential of quantum teleportation extends far beyond convenience and travel. In medicine, it could usher in a new era of instant diagnosis, treatment, and even organ transplantation. Imagine a world where critical medical supplies and organs for transplantation could be teleported instantly. Remote areas and disaster zones could receive essential medical resources in the blink of an eye. Teleportation could revolutionize surgery, allowing the world's best surgeons to operate remotely. This could democratize access to specialized healthcare. Imagine a device capable of scanning a patient's body at the molecular level, instantly detecting diseases. This early detection, combined with the ability to teleport targeted therapies, could lead to significantly higher survival rates. The implications of teleportation for healthcare are vast and transformative. Beyond its implications for our daily lives and our health, quantum teleportation holds immense potential for scientific discovery and exploration. Imagine being able to instantly transport scientific instruments and researchers to distant planets. Teleportation could revolutionize space exploration, allowing us to study distant worlds in unprecedented detail. The ability to teleport information instantly would transform the way we conduct scientific research. Imagine scientists in different parts of the world collaborating on experiments in real time. This could accelerate the pace of discovery in fields like medicine and particle physics. Teleportation could allow us to study extreme environments currently inaccessible to us. By teleporting sensors to these locations, we could gather valuable information about the inner workings of our planet and the universe. The possibilities for scientific exploration in a world with teleportation are vast. It's a future where the boundaries of human knowledge are limited only by our imagination. As we stand on the precipice of this quantum revolution, it's both exhilarating and humbling to consider the potential of teleportation to reshape our world. The possibilities we've explored, instant travel, revolutionized healthcare, boundless scientific exploration, seem ripped from the pages of science fiction. However, we're still very much in the early chapters of this story. Teleportation, especially on the scale of molecules, remains a formidable scientific and technological challenge. The intricacies of scanning and capturing the complete quantum state of complex objects are hurdles that will likely take decades to overcome. But as with any grand scientific endeavor, the journey is just as important as the destination. The pursuit of teleportation pushes the boundaries of human ingenuity. Each experiment brings us one step closer to unlocking the secrets of the quantum realm. The future of teleportation is a story yet unwritten, a tapestry woven from the threads of scientific curiosity and technological innovation. The prospect of molecular teleportation ushers in a host of ethical and philosophical quandaries. At the heart of this dilemma lies the question of identity. If we can perfectly replicate a human being, is that replica truly the same person as the original? Imagine stepping into a teleportation pod, your body dissolving into a stream of quantum data, only to be perfectly reconstructed at a distant location. Your memories, personality, and sense of self all intact, but are you still you? Or have you simply been replaced by a perfect copy, an echo of the original? Is our identity solely defined by the information encoded in our physical forms, or is there something more? If we can create perfect copies of ourselves, does that diminish the value of human life? These are questions that we must confront as we venture further into the uncharted territory of molecular teleportation. Section 3. Navigating the Quantum Frontier, Balancing Promise and Peril. The pursuit of quantum teleportation requires a delicate dance between embracing its potential and acknowledging its inherent risks. It's a journey into uncharted territory, fraught with both exhilarating possibilities and unforeseen consequences. The benefits of teleportation are undeniable. The ability to transmit information instantly across vast distances could revolutionize communication, transportation, and healthcare. But with this power comes a profound responsibility. The ability to manipulate matter at the quantum level raises ethical concerns. How do we ensure that this technology is used for good, not for harm? The act of replicating human beings could have unintended consequences for our societal structures. As we stand on the cusp of this quantum revolution, it's imperative that we proceed with both caution and courage. Section 1. Quantum computing unlocking the teleportation potential. The rapid advancements in quantum computing are breathing new life into the concept of teleportation. Quantum computers harness the principles of quantum mechanics to perform calculations at unimaginable speeds. This computational prowess could be the key to unlocking the complexities of teleportation. Imagine a quantum computer capable of processing vast quantities of information encoded in the states of entangled particles. Quantum computers utilize qubits, which can exist in a superposition representing both 0 and 1. This allows quantum computers to perform calculations exponentially faster than classical computers. For teleportation, this computational power could be revolutionary. Imagine feeding a quantum computer all the information about an object, creating a detailed quantum blueprint. As quantum computers become more powerful, they could provide the computational muscle needed to tackle the immense challenges of teleportation. Quantum computers and the quest for teleportation. Quantum computing can simulate complex physical systems, including those governed by quantum mechanics. Richard Feynman proposed simulating the quantum world using quantum computers. This could lead to teleportation by simulating matter at the quantum level. Imagine simulating every atom and electron in an object. Such simulations could reveal the intricate dance of quantum states. Understanding these relationships might allow us to teleport objects by manipulating quantum states. Section 3. A dance of data, capturing, controlling, and transmitting quantum states. The success of teleportation hinges on capturing, controlling, and transmitting fragile quantum states. Imagine juggling 1,000 soap bubbles, each representing a delicate quantum state. This precision is required for teleportation. Capturing complete quantum information without altering it is a key challenge. Quantum systems often collapse into a single state when observed. Techniques like using entangled photons help minimize disturbance. Transmitting quantum information is fraught with challenges. Quantum information is susceptible to noise and interference. Quantum repeaters boost the signal and correct errors. Quantum entanglement could create instantaneous communication channels. Reconstructing the object with perfect fidelity is the final challenge. Manipulating matter at the atomic level is currently beyond our capabilities. Advancements in nanotechnology and materials science are bringing this goal closer. The journey toward teleportation is a testament to human ingenuity. The potential rewards are extraordinary, redefining distance and possibility by the laws of the quantum world. The promise and peril of instantaneous travel. Teleportation, once science fiction, now a tantalizing possibility. Imagine traveling instantly, bridging vast distances in a blink. Breakfast in Paris, lunch in Tokyo, dinner in New York. No airports, traffic jams, or jet lag. But with promise comes peril, security, privacy, and misuse. Section 2. The moral maze. Ethical considerations in a teleportation age. As we stand on the cusp of this teleportation revolution, we must proceed with a deep awareness of the ethical dilemmas that lie ahead. The ability to deconstruct and reconstruct matter forces us to confront profound questions about the nature of life and consciousness. If we can create a perfect copy of a person, is that copy truly the same individual as the original? What happens to the soul, the consciousness, during this process? These are not questions with easy answers, but they are questions that we must grapple with. The potential for abuse is also a grave concern. Imagine a world where individuals could be teleported against their will. The ethical implications demand careful consideration. Quantum teleportation and the future of humanity. The pursuit of quantum teleportation represents the boundless potential of the human spirit and our drive to push boundaries. Imagine exploring the cosmos through instantaneous leaps of teleportation, teleporting probes to distant stars, gathering data from black holes, and establishing outposts on planets light years away. Using teleportation to harness resources from asteroids, tapping into the vast energy potential of the sun, and establishing communication links with extraterrestrial civilizations. A future where the impossible becomes possible and the universe unfolds in all its wonder.